All right, case of Professor Paluch debug some code. Student request for help on exercise 8.3. If you want some details for setting that up, look at those screencasts, which I work out the setup. Okay, so exercise 8.3, let's go take a look at what we've received. All right, so here's the M file. Cool. And to look at it's set up to solve the case of series or parallel. You just say what type you want. So I'm guessing type is a numerical value. Okay. So clear figures. So initial concentrations of A, B, and C. R is my gas constant. T, converting my activation energy. K naught 1. So then K1 we can just pre-compute since my activation energy R and T are constant and K not 1 is just constant. So that's good. Create a vector of taus going from 0 to 1 in increments of 240. And so you don't necessarily need 0. You know the initial concentrations at time equals 0. But let's see what we have. So the comment that I received is more so that they received some errors and wanted to know what was going on. Okay. All right, so we have logical block happening here. Okay, actually, let me maximize this. Okay, so if reaction's type 1, so it's a numerical value. So here's my check if type equals 1. So this is a parallel case. So A is my reactant in reaction 1 and 2. B is my product in 1. C is my product in 2. So that's fine. Computing activation energy for E2, which is the same as E1. K naught 2. Okay, so right now they're just having it hard-coded. And, you know, a tip, you might make this an input as well, that multiple. And we could look at that in a second. So there's K naught 2. K2 is just K naught 2 times my Arrhenius term. Now I'm going to loop over my values of tau. Final solve is, okay, so I'm going to look at concentration solver. Then res is, okay, so it looks like we're trying to solve for A, B, and C. Okay, this is all looking really good. And then this should be essentially the same thing. Stoichiometric coefficients just change, right? And heck, if you wanted to simplify your, well, no, not only do those change, but your error function is going to change because you're going to have a different rate expression. So, okay. All right. All right, so let's look at concentration solver. So we have CV. Okay, so CV is just the concentration I'm trying to solve for. So you unpack it, so that's CA, CB, and CC. Okay, so that is good, all right, and that's what I'm trying to solve for, concentration of A, B, and C. Then next comes my stoichiometric coefficients, okay, and I'm just picking up, yeah, VA1, VB1, stoichiometric coefficients. Okay, oh, okay, so here, okay, so now tau. Now capital tau here, right, so capital tau here is my vector tau values, but I'm just passing the nth value. So this is a scalar. So my function has its own workspace, right? Tau is just a scalar, so it's a little different. And as I click on it here, t is tau times 60. So that we just have to look at your units and see what you're getting at in units here. You know, is tau meant? So it would seem like you're doing tau in minutes. And then here you're converting from minutes to seconds, right? So a comment to explain that might be good because K naught has units of inverse seconds. So you're going, so you want to convert tau to seconds so you have consistent units. So I'd say maybe up here when you create your vector of times, then my guess is this is minutes, all right? I'm guessing it's minutes because you're multiplying by 60. So my guess is you're going from minutes to seconds, knowing that in my rate expression, K naught has units of seconds. Okay, but then we have CA naught, CB naught, and CC naught, which are needed in my mole balance design equation. K1 and K2, these are my rate constants which are computed up here. Okay, so that all looks good. Okay, so there's tau, so that's all good. Okay, so again, converting to seconds because K1 and K2 have units of inverse seconds. Okay, so that's good. Concentration of A and B will just be consistent with CA naught, CB naught, and CC naught. So that looks good. Then you pack it up and return it. Okay, so nothing glaring is staring at me in terms of something being wrong. Okay, so let's restore your code. Let's try and run it. So if I run reactions, let's do type 1, what happens? Okay, so I get an empty plot. Let's see what our error message is. Index exceeds the number of array elements 2. Error in reactions concentration solver line 100. Okay. So let's just look at one. Okay. So what's going on here is if I look at my error function, okay, so CV, right? CV is essentially what I'm trying to solve for, right? And so CV, I unpack here into CA, CB, and CC. So I'm trying to solve for a concentration of A, B, and C. So I take CV, because remember, fsolve expects an error function with a single input. And so I have this input of CV, which I then unpack. And again, unpacking something I like to do, so then it becomes clear in my expressions what CA, CB, and CC is. So I unpack CV into its 3 components, CA, CB, and CC. Okay. Now the issue is, okay, what this is telling me is when I call fsolve, okay, I only give it 2 initial conditions, right? So you can see it here. Which case is this? This is case 2. When I call fsolve, I just give it 2 initial guesses, right? So this would be initial guess for essentially A and B, and then same thing up here, initial guess for A and B. So what this is telling fsolve is fsolve's expecting an error function in which my vector has length 2, right? This is telling it that I have 2 unknowns that I'm trying to solve for. So this would tell fsolve that CV should be a vector of length 2. Okay. The issue though is that in your code you're trying to refer to the 3rd element of CV, right? Because you unpack it into 3 elements. So it's saying that when you unpack it, you're unpacking, or within your code you refer to the 3rd element of CV, but CV is only a vector of length 2 because you're only giving it 2 initial guesses here. Okay. So I think let's just try and give it a 3rd initial guess, and just going with what you have, okay, and we could play with the initial guesses, but that should at least get rid of this error message. Okay. Okay, so we get something. Let's see. Yeah, we get something all right. Okay, we do get negative times, and we have concentrations which are unphysical. Okay, but let's check this out because it's at least solving. Okay, and so what I'm looking at is, let's see, what do you get for your initial concentration of A? Okay, so now it's solving. Now we're just going to look at some particular details. So your initial concentration of A is 2 molar. So do you convert that somewhere? No. Okay, so where I'm going to check things up is, what's looks funky to me, okay, for lack of a better word, is at time equals 0, concentration of A is huge, right? Remember, CA naught is just 2. So what is going on here is really beyond me. And then concentration of C looks like it's increasing unbound. So we just need to look at some fine details of your code and try and see where we might have a small mix-up. Okay, so let's maximize this and let's go through this with the fine-tooth comb. Okay, but that fixes that error. And now let's look through it and fix it up. Okay. So concentration of A, B, and C in units of moles per liter. Good. So R is in joules per mole Kelvin, temperatures in Kelvin. E1. So remember, activation energy is provided in kcals per mole. So multiply by 1,000, so that's calories per mole, and then 4.184. So that should be conversion from calories to joules. So 1 calorie is 4.184 joules. Good. Okay, I get that. Okay, now it's a pre-exponential term, 2.4 times 10 to the 8 seconds inverse. Okay, that's fine. And so then I have K naught 1 times the X. Actually, it's 10 to the 8th. Okay, I'm just trying to make sure. Times the exponential of negative E1 over RT. Looks fine. Okay, tau. So my tau is going to go from 0 to 240 in increments of 1. Okay, so again, tau is in units of minutes. Okay, that's also get that from your plot. So tau is in units of minutes. Create a vector of A, B, and C in which I'm going to store my results. Okay, so type 1 is parallel. So A is going to be my reactant in reaction 1 and 2. B is my product in reaction 1. C is my product in reaction 2. E2 is just E1. It's fine. K naught 2 is just 0.1 times K naught 1 for this specific case. That's fine. Then K2 is K naught 2. Okay, that's fine. Okay, now let's look at this. So one thing I'm going to look at is, do all these variables match up? So let me just copy and paste this, okay, just so I can kind of get everything in one screen. Okay, I'm going to go down to my error function here. Okay, so first I have CV, which is my vector of the concentrations I'm trying to solve for. Stoichiometric coefficients in the right order. Okay, tau is specific value of tau, because I'm just passing that nth tau value. CA naught, CB naught, and CC naught. Okay, that looks fine. Okay, so let's delete that. So I unpack CV, CA, CB, CC. This is parallel, so R1's K1CA, R2's K2CA. Tau here, so make a note. Converting tau from minutes to seconds. And I'm doing that because my K1 and K2 values here are going to have units of inverse seconds. And so I want tau in seconds, so seconds times inverse seconds, dimensionless, and I'm just left with units of concentration, which is how I have things set up. Okay, so let's see now. Tau times nu A1 times R1 plus nu A2 R2 minus CA minus C naught. That looks fine to me. Then I pack it up as res 1, res 2, res 3. Okay, this looks completely fine. Okay, so then what's going on? Okay, let's play around with my initial conditions. So initially I have 2 molars of A and 0 of B and C. So let's just say 1, I don't know, 0.1 and 0.1. Okay, let's see if by some chance fsolve doesn't like having an initial guess of 0. No. Okay, let me look at plot. Let's see if something's... Okay, so come on and get my head out of this way. oh, your axes are goofed up. Okay, so, well, your axes labels and such are flipped. So if I look here, you have this labeled as concentration, and this labeled is time or tau, but it should be the opposite. So remember, plot is x comma y. So it's your independent variable versus your dependent variable. So you just have these labeled in the opposite way, and I should have noticed that this is going from 0 to 240, and this is going from 0 to 2. Okay, so it looks like then the last piece of the puzzle is just fixing your plot command. Okay, where were you? Plot. So plot here. Okay, so what I actually want is tau comma a. Tau comma b. Tau comma c. So then I have concentration of species over time. Yeah, so now my x label is time. If you want to be nerdy, / tau should give me a Greek tau. Yeah, moles per liter or molar. Looks good. Okay, so now let's save this. Let's run it again. Beautiful. All right, so now this is looking good. Okay, and so now you would also add, say, your plot of selectivity, and where you just need to be careful again is that, in this case you can see at time equals 0, the concentration of C is essentially 0. So B takes off, but C remains, really, really small initially. So just be conscious of those values of your selectivity. But this is a beautiful plot. A couple comments then would just be adding in a plot for selectivity, and then maybe saving your plot to a window as well, or to file as well. Okay, cool. Okay, if we want to have some more fun with this code, we can, since you're the one that asked for help. Yeah, maybe let's add. Well, you can add the documentation. Let's add, say, an input of multiple. Okay, where multiple is just going to be that constant I'm multiplying k naught 2 pi. Right, so what I can do then is, where was it? So like you're saying for now k naught 2 is 0.1 times k naught 1. Right? You can actually make that multiple an input. Okay, so the user can specify what they want that multiple to be, or just making it easier on you. So I need to update it here as well, right? Just making it easier on you. Then in terms of running the different cases, you can just make it an input. Okay. Yeah, and that could help you as well. And then, if you wanted to, you could even, have that update your plot, right? You could, make an input that's a string, and then that string could become, say, your title in your plot. Or I believe there is a MATLAB command to convert, your num to string, but it should be just as easy if the user is going to input that multiple, have them, customize their title, right? And so I could do, like title, and they could specify what the title is. So maybe, okay, just as an example, concentration of species over time, right? Let me just replace this with title, all right? And you have it nice where this is going to be the same regardless of, of whether it's parallel or series. Okay, so maybe when I call this then, okay, now I have that. I'm going to do a multiple of 0.1. And my title is going to be, I should have seen you had concentration versus time, but let me just do, say, k naught 1 is equal to 0.1 k naught 2. Okay, and actually let me make sure that's how we have these multiples set up. Multiple, so k naught 2 is equal to 0.1 times k naught 1, right? And so you could even add that custom title as an input. Oh man, now I broke everything. Oh. Hold on, now I managed to break it. What did I do? Title. Oh. Okay. need to be careful, right? Title means something in MATLAB. So one more time. Title. Okay. So the issue I had is I was using title as a variable name, where title is the MATLAB built-in function to add your title to your plot. Okay. It's my bad. Okay. Cool. All right. So now I can even add a custom title based on the case. And that guy could have changed that to parallel. K02 is equal to 0.1 K01. Now, if you do that string with title, you can also use that then as, say, the name of your figure as you save it, right? Okay, so just for completeness, again, you're the one that asked for help, right? So I can go overboard then having fun with this. So I could do print, say DEPSC. So I like to print a postscript. You might do a DPNG. That's up to you. Let me just do plot title. Okay. And so now what I can do is, let me say this is K02 is equal to K01. Well, actually, now I take this back because I'm going to have to worry about special characters. Okay. If I could do, say plot name. And I can even add that as an input. So I can't just use the title because I'm going to have issues with improper, I'm going to have issues with the name of the file and, these extra periods and stuff like this. And so plot name might be parallel. Let's do 01 K01. Okay, just so I know that it's 0.1 times K01. Okay, so hopefully if I run it, the title should be the same. That's fine. Okay. EPSC. EPSC. Try again. Okay, title's the same. Bam. Now my figure opens up. I just forgot to make my flag a string. Okay, so that's my bad. So now I could even open that outside MATLAB, right? And I have my beautiful plot. Okay, cool. So let's close that. Okay, and again, last issue with my print command is I just forgot to put the single quotes on my flag to make it a string. Okay, but yeah, so cool. So now I've even added plot title and name as inputs and have that multiple as an input. So you can just crank out all 6 of those cases, readily generate those plots, all with unique names, and then just put those in your report and compare them. Again, you would add a plot for selectivity, so you should add that, the calculation of selectivity. But I think that's it in the problem, right? All I ask for is selectivity. Okay, hopefully that helps.